In this video, we are continuing with the sums of exercise 4.4 of the lesson Applications of Derivatives. Question number 8. If the demand function D is equal to P plus 6 upon P minus 3, find the elasticity of demand at P is equal to 4. Now, to find the elasticity of demand, we need derivative of D with respect to P. So, D is equal to P plus 6 upon P minus 3. D by dP is equal to, we have to use U upon V or rule or quotient rule of differentiation here. So, the denominator into derivative of numerator minus numerator function into derivative of denominator divided by denominator the whole square. Therefore, P minus 3 into derivative of P plus 6 is 1 plus 0 minus, we are differentiating with respect to P's. Therefore, derivative of P is 1 and constant 6 derivative is 0 minus P plus 6 into derivative of P minus 3 is 1 minus 0 divided by P minus 3 the whole square. Now, opening these brackets, we will get P minus 3 into 1 P minus 3 minus P plus 6 into 1 P plus 6, but remove the bracket, then both the term will get negative sign. So, minus P minus 6 divided by P minus 3 the whole square. P and minus P get cancelled, remaining minus 9 upon P minus 3 the whole square. Therefore, eta is equal to, we use the formula minus P upon D into D by dP. Eta is equal to minus P divided by, demand function is P plus 6 upon P minus 3 into D by dP is minus 9 upon P minus 3 the whole square. We can cancel P minus 3 from these two functions. So, P minus 3 from P minus 3 from this bracket and 1 P minus 3 from this also get cancelled, and remaining minus P into minus 9, 9P into P plus 6 into P minus 3. Substituting P is equal to 4, we need to find eta when price is equal to 4. We get eta is equal to 9 into 4 divided by P plus 6, that is 4 plus 6, and P minus 3, 4 minus 3. On simplification, we will get 36 divided by 10 into 1, 10. So, 36 divided by 10 is 3.6. Therefore, elasticity of demand at price P is equal to 4 is 3.6. Question number 9. Find the price for the demand function D is equal to 2P plus 3 divided by 3P minus 1 when elasticity of demand is 11 upon 14. Given given values, elasticity of demand eta is equal to 11 upon 14 and demand function D is equal to 2P plus 3 upon 3P minus 1. Now, we need to find the price. So, we will differentiate this with respect to D, that is D by dP is equal to, again we use the quotient rule, the denominator into derivative of numerator minus numerator into derivative of denominator divided by denominator square. That is 3P minus 1 into derivative of 2P plus 3 is 2 plus 0 minus 2P plus 3 into derivative of 3P minus 1 is 3 minus 0 divided by 3P minus 1 the whole square. Now, we will open these brackets and expand, then 6P minus 2 minus 6P minus 9 we will get, and that is 6P minus 6P got cancelled, minus 2 minus 11 minus 9 is minus 11 divided by 3P minus 1 the whole square. Now, we will use the formula of eta, that is elasticity, minus P upon D into D by dP, that is substituting the values, eta is given as 11 upon 14 and minus P divided by demand function is written here and the derivative with respect to P also, minus 11 upon 3P minus 1 the whole square. Now, we will cancel 3P minus 1 from these two functions. So, we will get 11 upon 14 is equal to 11P divided by 2P plus 3 into 3P minus 1. 11 also can be cancelled in this step only, but 11 we cross multiplied both the LHS and RHS functions. 11 into 2P plus 3 into 3P minus 1 is equal to 11P into 14. That means we will cancel 11, then remaining brackets we will expand, that is 6P square minus 2P plus 9p minus 3 is equal to 14p. Now 6p square plus 7p minus 14p minus 3 is equal to 0. And again simplify, we will get 6p square minus 7p minus 3 is equal to 0. That is a quadratic equation in p. Now we will solve this equation to find the value of p. That is the quadratic equation 6p square minus 7p minus 3 is equal to 0. Now you can use any method to solve this equation and find p. Here I used the splitting of middle term and factorized. Then 2p minus 3 into 3p plus 1 is equal to 0. Then it is a product of two terms equal to 0 means one of them should be 0. Either 2p minus 3 is equal to 0 or 3p plus 1 is equal to 0. From 2p minus 3 is equal to 0, we will get the value of p as 3 upon 2. And from the second one, 3p plus 1 equal to 0, we will get p is equal to minus 1 upon 3. But we know price is never negative. So, we will consider the positive value of p as 3 upon 2. That means, the price for elasticity of demand eta is equal to 11 upon 14 is 3 upon 2. Now, question number 12. A manufacturing company produces X items at a total cost of rupees 40 plus 2x. Their price is given as P is equal to 120 minus X. Find the value of X for which revenue is increasing and profit is increasing. Also, find the elasticity of demand for price is equal to 80. So, first one we will consider first, that is revenue is increasing. Let C be the total cost function. C is equal to 40 plus 2x. Now revenue is price into demand. Here the price is given as 120 minus x and demand is for x item. So demand is taken as x. So P into x, that is 120 minus x into x. Expanding the bracket we will get 120x minus x square. That is dr upon dx is equal to. That is from this we need the value of the revenue is increasing, so we will find the value of x when considering the first derivative is greater than 0. So we will first find the first derivative of r with respect to x. dr upon dx is equal to 120 minus 2x from this r. That is 2 is common, therefore 2 into 60 minus x. Now we have the revenue function is an increasing function. So dr upon dx is greater than 0. That means 2 into 60 minus x is greater than 0. And this is positive means 2 is positive. Then the second term also should be positive. Then 60 minus x greater than 0. And 60 greater than x. So x is less than 60. That means value of x when revenue is increasing is x less than 60. Now question number 12, second one, profit. Profit is equal to revenue minus cost, that is r, pi is equal to r minus c. R is 120x minus x square minus c is 40 plus 2x. Now we'll expand this bracket, open this bracket, 120x minus x square minus 40 minus 2x. Therefore pi is equal to minus x square plus 118x minus 40. Now, we will find the first derivative with respect to x, that is d pi by dx, which is equal to minus 2x plus 118 is equal to 2 into minus 18 plus 59. Now, since profit function is an increasing function, what is the condition given? So, d pi by dx is greater than 0. That is 2 into minus x plus 59 greater than 0. And 2 is positive, then minus x plus 59 also will be positive or greater than 0. So 59 greater than x, that is x less than 59. That is the profit pi is increasing for x less than 59. Now question number 12, third one, to find the elasticity of demand. The given price function is p is equal to 120 minus x. Then x can be written as a function of p also. That is x is equal to 120 minus p. Then we can say that x is a function of p means it's a demand function. So x is the demand function. Now we can find the derivative of x with respect to p, that is dx upon dp is equal to 0 minus 1, because derivative of 120 is 0 and derivative of p with respect to p is 1. Now 0 minus 1 is minus 1. Now we will use the formula of eta or elasticity of demand as minus p upon d into dd by dp. So we will just directly took the value of demand as x and derivative is dx upon dp. So eta is equal to minus p upon 120 minus p, that is x, and dx by dp is minus 1. That means minus p into minus 1 is p and divided by 120 minus p as eta. Now we have the condition p is equal to 80, price is 80. So eta is equal to 80 divided by 120 minus 80, that is 40. 80 divided by 40 is equal to 2. That is the elasticity of demand for p is equal to 80 is eta is equal to 2. Now question number 13. Find MPC, MPS, APC and APS. What are these MPC, MPS, APC, APS? Marginal propensity to consume, marginal propensity to save, and average propensity to consume and average propensity to save. If the expenditure function EC of a person with income I is given as EC is equal to 0.003 into I square plus 0.075 into I when I is equal to 1000. So we need to calculate all these terms when I is equal to 1000. So we will start with the given function expenditure function EC is equal to 0.0003 into I square plus 0.075 I. Now we know marginal propensity to consume is the derivative of EC with respect to I. That means 0.003 into derivative of I square with respect to I is 2I plus derivative of 0.075 into I is 0.7075. Now that is when we simplify we will get MPC is equal to 0.0006 into I plus 0.075. Now we will substitute I is equal to 1000 in this. On simplification we will get MPC as 0.675. You can see the calculation here. Now we have one relation MPC plus MPS is equal to 1. That is MPC is 0.675 plus MPS is equal to 1. So MPS, that is marginal propensity to save, is equal to 1 minus 0.675, that is equal to 0.325. Now APC, average propensity to consume, is EC divided by I. That is 0.0003 into I square plus 0.075 into I divided by I. We can cancel I from both the terms and from the denominator. So APC is equal to 0.0003 into I plus 0.075. That is, now we will substitute I is equal to 1000 in this also to get APC. So after substituting and simplifying we will get APC as 0.375. Now again we have the relation of average propensity to consume and average propensity to save. That sum is equal to 1. Now substitute APC is equal to 0.375 plus APS equal to 1. So APS is equal to 1 minus 0.375. On simplification, we will get APS equal to 0.625. Therefore, for I is equal to 1000, we have MP is equal to 0.675, MPS is equal to 0.325, AP is equal to 0.375, APS is equal to 0.625. Now, this much is the lesson application of derivatives. So, you have to study well because we are going to give the first semester, first prelim exam. Thank you.